there, ladies and gentlemen. Welcome to 11.4 Common Logs and Natural Logs Notes. Today we finally get to use that log button on our calculator that some of you have been dying to use. So go ahead and grab your calculator. And our first problem, we're going to just type in log 3. So find your log button, which would be there, and then 3. And hit enter. And let's go ahead and round to 4 decimal places. So we're going to say 0.4771. 0.4771. Don't reach decimal. And now we're going to put in our log of 0.2. So log of 0.2. And we end up here with a negative 0.69897. So if we go to 4 decimal places, we're going to have to do a little rounding. So that 9 and then the 7 after it tells us to round that up. So we'll be negative 0.6990. So negative 0.6990. And what we just used is our common log. And common log has a base 10. So that would be like if it's a log base 10, that's the same thing as just plain log. So we use our log base 10 or common logs when both sides of my exponential equation can't be easily rewritten as powers of the same base. So this isn't in your notes, but this example here that I'm moving around a little bit. If I rewrite 27 as a base of 3, so 3 to the third power is 27. And now both my bases are the same, so I can say x equals 3. Now if I look at problems like 3 and 4, I cannot rewrite 11 having a base of 3. So this is going to be the common log then of 3 to the x equals the common log of 11. Now x is an exponent in our log, and so we have to do something special with that. We're going to take that x and move it out front. So x times the log of 3 equals the log of 11. And because of this, it's x times log of 3. We are going to go ahead and divide by log of 3 to cancel that here. So we get x equals the log of 11 divided by the log of 3. So grab those calculators. Let's slide mine over a little bit. Oops, that did more than I wanted to. So let's try that again. Slide it over a little. No, whatever. We'll do that here. Log of 11. And then you just want to make sure that you close that parenthesis off. And then do your log divided by log of 3. Great. So if we go ahead and take that, and we're going to again, let's just go to 4 decimal places. So 2.1827. So we end up with x equals 2.1827. Ooh, I just spoke wrong. Yeah. 2.1827. Gotta make sure my rounding's right for you guys. All right, then let's go ahead here and look at this next one. I cannot make 6 into a base of something that is the same as a base 42 into a base of something. I can't take 6 to make it into a base 2. I can't take 42 and make it into a base 7. I mean base 6. So we're going to take the common log on both sides. We're going to move that x out front. So x times the log of 6 equals the log of 42. Now to get x by itself, we're going to divide by the log of 6 on both sides. So x equals the log of 42 divided by the log of 6. So again, take your calculator and put 42 in, and then put a close parenthesis. Divided by log of 6. Let's go on to 4 decimal places. So we end up here with x equals 2.0860. Just watch your directions when we get to your homework if I want. I'm pretty sure they all say 4 decimal places, but just double check. All right, so So this is a little off of your notes. We're going to do a couple of conversation things, and then we'll get to back to our notes. So natural logs are just regular logs with a base e. So that's kind of what we talked about. Log base e is going to be a natural log. And so base e is a number, just like pi is a number, e is also a number. And a lot of times scientists use e when we're talking about things that grow really big or get really small really fast. Interest formulas, so in business classes, we use the number e. So let's just find out where e is on our calculator, and natural log is that ln. So if I have ln button on your calculator, that one's there. And if you look at the little blue above it, that's e to the x. So to get that, we hit second ln, and that gives, oh, there it went away. And that gives us our e. So let's do e squared. Okay, then let's go ahead and type into our calculators e to the negative 1.3. So second ln negative 1.3. And you want to do, make sure you're doing this on your calculator too. I know it's easy to just watch me do it, but you want to try it just to make sure that you're getting it typed in correctly and we're getting the same thing. So natural log of 4. Oops, not plus. And then natural log of 0.05. All right, hopefully you got all those same values as I have on my calculator. If you don't and you can't get it figured out, just stop in and we'll get that worked out together. All right, so let's go ahead and talk about natural base e. So like I said, it's an exponential function. It looks like this. So when we started talking about logs, we talked about them in exponential form and then logarithmic form. Natural base e is our exponential form, and then natural log form is going to be the log form of it. And that's going to be here. And these two are inverses, so it means that they are reflective over this line of y equals x. So the two examples here say write it in equivalent exponential or logarithmic form. All right, so if we look at our first problem, if we're gonna, it's in exponential, we're gonna write it in logarithmic form. So log, our base is e of 5 equals x. But now, instead of saying log base e, this is when we replace it with natural log. So we'd say natural log of 5 equals x. And now it is written in logarithmic form. If we look at b, it's given to us in logarithmic form, and we're going to write it in the exponential form. So I'm going to replace ln with log base e of x equals 0.6931. So now it's in log form, and I'm going to convert it into exponential form. So e is my base, and my exponent, that is my 0.6931, and that is equal to x. Now it is in exponential form. So we replace ln with log base e. We're going to do the same thing in our problems. Like if we have log base e, we can write it as ln. If we have ln, we can write it as log base e. Those are interchangeable. All right, so the reason we talk about those as being interchangeable, we talk about inverse operations. So if we have 2x equals 4, it's 2 times x, so we're going to divide. That's the inverse. If we have x squared equals 9, we're going to take the square root on both sides, because that's the inverse of squaring something. If I have the log of base 3 of x equals 10, we're going to put it into exponential form, because that's the inverse. So e to the x and natural log of x are inverses. So that's how we use them, is to help get rid of that e to the x then. All right, so let's start in this first one. Just like solving any other equation, we are going to isolate the variable, and that is in the exponent of e. So the first thing we're going to do is we're going to add 7 to both sides. So 5 e to the negative x equals 9. Our goal, again, is to get that e term by itself because it has an exponent, so we're going to divide both sides by 5. Now, I know our temptation generally is to take 9 divided by 5 right into our calculator, but we want to leave it like that just for now. All right, now I have something in exponential form, so I'm going to write it in logarithmic. So I would say log base e of 9/5 equals negative x. Now it's in logarithmic form, and I have log base e, so I can replace log base e with the natural log. The natural log of 9/5 equals negative x. So if I want x to be positive, I'll just divide by -1. So x equals the negative log, natural log of 9/5. So grab your calculator and type in negative natural log 9 divided by 5. So it should just look like that. When we do that, we get negative 0.587, and then let's round up to 8. X equals negative 0.5878. Okay. So we have to get the e by itself. That's in exponential form. We're going to convert it into logarithmic form and then replace log base e with the natural log. Okay, so let's go ahead and try problem 7 and 8. Actually, I want you guys to pause and try 7 all by yourself, and then come back and you'll see my workout, and we'll see how we did compared. All right, so take a look here. The first thing we want to do is subtract over that 2 to both sides. So we get 3 to the ex equals 2. So we're going to divide both sides by 3. Now it's in exponential form. E to the x equals 2/3. So we're going to write in an exponential. That's that blue portion of log base e of 2/3 equals x. So then you're going to go ahead and change log base e into natural log. And so the natural log of 2/3 is negative 0.4055. So that's where our answer is. I want you guys to pause the video here. I want you to try problem 8 here on your own, and then come back together and we'll see how you did. All right. Hopefully you have gotten a chance to try that. We add 9 to both sides. We're going to divide by 4, so then our e to the negative x equals 7/4. Now we can change that into logarithmic form, which is the red one. Log base e of 7/4 equals negative x. We can change log base e into natural log. We can replace that right there. So then we get the natural log of 7/4 equals negative x. We want to take that negative over by dividing by negative. So negative natural log of 7/4. And that gives us negative 0.5596. All right. So as I mentioned before, we use E in the compound interest formula where we compound continuously. So that means like the money is always being added, and then the interest is being calculated on that new amount. So that is called our PERT formula. Often you'll hear it referred to as our PERT formula. So if we have about $1,000 in an account, and we're paying 2.5% annual interest, and it's compounded continuously. So remember, when we talk about rate, we want to move the decimal point over 2 so that it is no longer a percentage. So I'm going to plug this into our PERT formula. 1,000 times e to the r, so 0.025 to the 10 years, so times 10. When you type this in, just make sure you put 0.025 times 10 in parentheses when you're typing this in on your calculator. Let's see if I can slide it over without making it huge, and I did. Okay. I might not be able to. No. Okay. Guess we're just going with it again. 1,000. Okay. And then we have second natural log to pull that e in. Now my calculator pops it up there. 0.025. 0.025 times 10. All right. So, and here we go. Now remember, it's money we're dealing with, so we want to go to 2 decimal places. So that's going to round to 3 cents. So $1,284.03. Don't forget your dollar sign goes in front of your money. So Part B says, how long will it take for the balance in your account to reach at least $1,500? So this one, we don't know our t, we're going to solve for our t. All right, so 1,500 goes into our 8. 1,500 equals 1,000 e to the 0.025 t. We have dealt with problems like this before. It's that this time we have an e in it. So we're going to start off by dividing by 1,000. When we divide by 1,000, we get 1.5 equals e to the 0.025 t. Now this is an exponential form. We are able to convert this or rewrite this into logarithmic form. So log base e of 1.5 equals 0.025 t. We can replace log base e with a natural log. All right, and now we want to get t by itself, so we're going to divide by 0.025. 0.025. Now pay attention, this is the natural log of 1.5, and you get that answer, and then you divide by 0.025. So just make sure when you are going into your calculator that you have the natural log of 1.5. Close those parentheses off before you go divide by 0.025. Oops, missed my 2. All right, so we get just over 16 years and 0.25 or 219. Okay, so make sure that you're doing this. If you are going into your y equals, you're going to be able to tell me, well, sometime after 16 years, but we are able to accurately find that. So go ahead and make sure that you do that. So I'll just jump back again so that you can see our work here. And we get t equals 16.219. All right, there you have it, ladies and gentlemen. Hope you have a great day.